Hey everybody, this is Larry. This is me going with Q3 of the weekly contest 289, maximum trailing zeros in a cornered path. And I think this is to me, I think this is probably the hardest problem on the contest, even though, I don't know, maybe, well, the top people will always be top, but even like the number one person, Uwe, spent more time on Q3. So I think this is probably the hardest problem in the contest. There are a couple of concepts you have to understand first. Right, one is what is a trailing zero, and there are a couple of ways to do this, and there may be simpler ways, to be honest, but I'm gonna go over my way. There's a couple of ways to do this problem in general, so hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Give me some love, because this is a rough contest on something that I could have done better. But so I have a disclaimer and a warning. We'll go over maybe a simpler solution afterwards, but my solution is definitely very not confusing, but it's more complicated than it needs to be. But we'll go over the concepts, and then hopefully I'll help you build what you need to do to build your solution to upsolve at home. And definitely do try to do that, because practice, you get perfect and all that other stuff, Okay, so the couple of things to know. The thing is about the trailing zeros part, right? So this part, it is mathematical. I did skip this part in the sense that I know how to solve it, but the idea about that is that the idea behind trailing zeros is that, okay, what's a trailing zero, right? So for example, you have 2,000. What does that mean? That means there's 2 times 1,000, so there's 3. But breaking down the 1,000, obviously 1,000 is equal to 2 times 5 times 2 times 5 times 2 times 5, right? So another way of saying this, of course, is that given a number, it has 2 to the 4 times 5 to the third, right? So then another way of saying it is, how many 2's are there and how many 5's are there, maybe? Because then if you times 2,000 by 5, then now, let's say we times this by 5, then now this becomes 2 to the 4th times 5 to the 4th, right? And then now, of course, that means that there's going to be 4 zeros instead of just 3. So that's basically the idea behind trailing zeros. So that So that means that for every series of numbers, so say here, let's just take this one, right? So here, you can break this down to 3 times 5. So that's, 3 times 5 times 2 times 5 times 2 times 5 times 2 times 3 times 1 times 2 times 5, right? In this case, you can kind of group them together, and then you go, okay, there are 1, 2, 3, 4 2's, and we only care about the 2's for now, and then 1, 2, 3, 4 5's. Oh, 4 5's as well, huh? Oh, did I count that wrong? 1, 2, 3, 4. 1, 2, 3, 4, huh? I think I vote. There's 1 5 here, and wait, what? Huh, did I mess this up? Hang on for a second. 1, 2, 3, 4, and then 1, 2, 3, 4. 2 times 5 times. Oh, no, okay. I had an extra 5 and 20. Sorry, I did, instead of 20, I did 100. That's why. Okay, so that means that the 2 to the third times, so then that is going to have only 3 zeros because they match up in that way. So that's basically the idea behind this one, and of course you can see in this example. That's why I knew that this would be only have 3 trailing zeros. So that's basically the idea. So that's part 1. Whew, yikes, right? So if you didn't know that one, it's gonna take you at least some time to figure it out. And of course, if you've seen it before, like I've seen this sub problem before, so that's why I was able to kind of get this, or like I knew that I had this idea immediately, right? And then now the second part is this really weird cornered path thing where you can only turn in one place. So there are definitely a lot of ways you can think about this one, I think. But the way that I thought about it is that, so given this grid, let's say we have this grid, right? Yeah, let me actually bring out paintbrush really quickly. Let me start drawing a little bit. Hang on. So this is like I said, this is a very hard problem. So don't feel bad if you took a long time. Even though there is an easier solution than the way that I did it, it's still a hard problem, if you ask me. Okay, that's fine. I don't need the entire thing. Y'all can see it, right? Okay. Yeah. So basically, for example, if you have something like this, I got it off screen. You know, the way that I've thought about it is that okay, they drew you this path that's like here and then here, right? But of course, you can think of it also as greedy because there's no reason why you can take here, and if you can only make one turn, you always want to go all the way to the right, right? Because why stop early? You're greedy, just keep going. And then now, then another way of thinking about it then is that for every cell, let's say this is the turning corner. Another way to think about it is that, okay, now we can go up, in this case, right, but up, down, left, right, say, right? And then now we have 4 places to go, right? So these are the 4 possible paths with this number as the turning corner. Of course, in 2 of those paths we don't turn, meaning going straight up and straight left and right. But you get the idea, right? So then the idea for me is then to do prefix sum. Is that okay? Let's say I have here, right? So then now let's get all the 2s. Let's count how many 2s and 5s are there to the right. How many 2s to 5s are there to the up, down, and up and left, right? So now we have these components, and we get the numbers of 2s and 5s, and then it just becomes brute force, right? Because then now you have 4 things. You have 4 choose 2, which is what, 6 possibilities. So that's fine, right? 4 times 3 over 2. And that's basically the idea. You just do a brute force of okay. Let's say we have this thing and then this thing. How many 2s and how many 5s do we have, right? Let's say we have this thing and then this thing. How many 2s and 5s do we have? And then, you know, you iterate through it, and then now you're here. You know, you do this one, and then you just add that. And of course, you have to add the center cell, because don't forget that cell. So that's basically the idea. And of course, you can actually build out prefix sum in a 1D dimension. Like, so basically the idea here, of course, is that you can actually build, you know, just count going this direction, how many 2s there are in a prefix sum kind of way, in a vertical prefix sum, how many 5s, and then you know, you could do some maths. For this explanation video, I'm not going to go over prefix sum because you really need to know prefix sum for this problem. I have a lot of prefix sum videos, so hopefully one of my fans would put a link in below, and you know, would love you for it and give you a shout out. But yeah, so that's basically the idea behind my problem. In terms of implementation, I actually did it differently a little bit, but that's still the concept. The way that I did it differently instead of using so you can have n prefix sums, 1 for each row, 1 for each column. I did it the other way, but 1 for each row, 1 for each column, and then 1 for 2s and 1 for 5s, right? So that's the way that you can do it very quickly. But the way that I did it is, yeah, the way that I did it is a little bit different. And of course, I think you can actually enumerate things in a little bit different way, but that's besides the point. So I think you can actually do things. There are some optimizations that you can do, because I think you're doing duplicate work, but that logic alone will be good enough for you to solve the problem. The way that I did it is that I used a 2D prefix sum, which I'm also not going to go over. I have other videos on that one, but yeah. So basically here, I have this get prefix function that lets me get the 2D prefix sum of divisors, or number of D's in the, is it divisors? In the prime, prime factors, right? And because obviously we only get 2s and 5s, so yeah. So, and this is what it looks like. This is just regular 2D prefix sum. Again, not going to go over this contest or this video, because I want to keep things tight. Just there are really there are many Leetcode videos on this one that I have, so definitely check those out or come to the chat and Discord and we'll chat about it. But yeah, but basically, yeah, as you can see, I just get the number of current, so it should be good. They're most 10 to the fifth element, and we do this for every element. And because because we divide it by 2 every time, this will only run at most like log 1,000. So this will run only at most 10 times. So this is going to be good. And of course, for 5, it's even less for obvious reason because it's log 5. Again, we have this 2D prefix array formula. Not going to go over it. Apologies. Check out those videos. And then at the end, this is, I wrote a lot of code and it took a long time because I actually ended up taking about 20 minutes because I had a lot of weird issues. I also, to be honest, I worried a bit about time limiting out in Python, so I didn't have this helper function. Once I wrote this helper function, this is easier, but I was trying to like reason it out every time, and that was just a mess, to be honest. And you could watch it in the video and see. Like I knew how to do this relatively quickly, but it took me a long time to implement. Today's not my implementation day, as you can kind of see from my Q1 and Q2s as well, and even Q4s, which was I was fast. I had a long submission. So anyway, check out my contest video if you want to see what happened there. But yeah, but like I said, this is pretty straightforward. After that, and even though it's a little bit yucky and I could have maybe cleaned it up, but this is just going up, down, left, right, and then now and also getting the cell from IJ itself, and yeah, and then we just brute force all the 6 possibilities because you have 4 things, and this is the number of 2s, this is the number of 5s, and then we get the max of the min of the 2 things to count the number of zeros because they pair up, they become zeros, they live happily ever after, and there you go. But yeah, this is a mouthful, right? So what's the complexity here, right? So it's going to be R times C because get prefix is going to be R times C. So this is linear. This is going to be O of 1. And as you can see, for each cell that we do 4 sets of O of 1 operations. And then this is O of 12 or something like that, right? So this is all going to be, this is all constant time. So that means that this loop is going to be R of times C because this is all constant, even though you may not see it, I don't know, but let me know, it's just confusing. But yeah, this is O of 1, so this is going to be R times C, and because these are R times C, everything is going to be O of R times C time and O of R times C space, because we only have, the only thing that we use spaces is 2 matrix, and maybe you could say that here we only contain 4 objects, and even if you repeatedly allocate it, it's going to be 4 times R times C. So linear time, linear space, R times C time, R times C space, because that's the linear input. That's all I have for this one. Let me show you the code really quickly. This is the top half, and this is the bottom half. Well, the bottom half is a little bit long, but hopefully this makes sense. So that here you have the up, down, left, right portion, and the current box, and then here's the for loop, brute force for loop, right? Anyway, that's all I have for this one. Hopefully this is good. Hopefully you did well. Let me know what you think. And you can watch me solve it live in the contest next. Okay, so this has been a very hard contest so far already. A couple of people, I'm really slow on this one. So yeah, have to catch up. At most 1 turn. What does at most 1 turn mean? This is so really thing. The math is probably okay. I feel like I already got how to do it, but I don't know what 1 turn means. Like, it doesn't even tell you where you're starting from. What is a corner path? left on the, okay, so these are not routed. That's why they were showing examples of not routed paths. There's more than one turn. So basically it has to go, so basically we want to go down and then left or right, and then, this is so awkward. What a weird problem. Am I doing okay? Yeah, I'm doing very slowly on this one. Basically the 10 to, wow, 10 to the 5th. I think this part is the more critical part one. Maybe I don't know how to do it. But basically, that means that if we do m times n, it'll be fine. Yeah, okay. Is that right there? I think my complexity is a little bit worse though. Yeah, I have to catch up on this one. Can I do brute force? Is that even well? No, I don't think so, because each of the paths, if you just do like a naive intersection, will have n elements, so it's m times n times n or something. MB. I don't know that you can. Oh, I see. That makes sense. So we do a prefix suffix thing, and then you can brute force. Okay, I think I got this now. I forgot about that. You cannot do another turn. I think that's the thing you have to take care of. Okay. Okay. Let's see. Yeah, prefix sum. Okay. Okay. I mean, this is actually not a easy problem, but it's doable, so it should be okay. But it's still kind of a tricky problem, if you ask me. Each element is less than 1,000, but if you have so many elements, then it's a lot. Okay, fine. Maybe I don't have to define like this, but also I think I need +1 for prefix. Okay. Let's see. Is equal to 0 while grid of ij is mod d is equal to Okay. I always do it this way. I feel like I don't remember 2D prefix sum very well. This is not right. Okay. Let's print them out real quick just to see. Okay. So there's 2, 3. Okay, that should be okay. 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 Wow. Yeah, Q3 is very hard, but people skipped ahead. So people finish. Oh, a couple of people finish away. Wow. I mean, I was very slow on Q1 and Q2. Just on silliness. Okay. Right. Okay. And then now we just do the brute force. Yeah. So now we go from each row. I think we can do a little bit. We don't need to do prefix on this one actually, do we? This is overkill, but maybe it's too late. Okay. So basically, another way of thinking about this is that given one space, I'm just trying to think about what is the best way to brute force this. And I think for each space you can go up, down, left, right. I think that's the idea. Maybe. Okay. I know I'm doing this, but it's just a little bit annoying to get right. Okay. Oh. It's just so easy to mess up too. Okay, I think I have an idea, another way of doing it. This is awkward too because I kind of want to make a function call, but I worry that about running time issues in Python, to be honest. This is what I want, but this is wrong, but okay. We have I j plus 1, we have minus I minus 1 j plus 1, we subtract I minus 1 j, okay, I minus 1 j. No, we did that. No, this is I j. Okay, so then here is I minus 1 j. Okay, so I'm wrong on this one. I do really want to make this a helper function, but I do, and this may be a premature optimization, but I feel like that's what I needed to do. Let's see. Right, so now this one is going to be R. Yeah. This is so error prone, don't recommend it. Is that fine? Yeah, I think that's fine. My only hope at this point is that this is going to be fast enough. I mean, in terms of solving speed, that it will give me a good enough score. Okay, so then now we want to, okay, just double checking. Yeah, this is going down. Okay, now I'm going to go to the left. So then that means that we're going to here on this row. Nope. Oh yeah, because we have to go to the left. So we're, is this right? I think I did mess this up. No. This is on. This is not down though, because the I should. What am I doing here? This is all wrong. Okay, so basically this is for I minus 1j, and then so this is where a function would help. Yeah, let's do a helper. I think I'm getting too silly with the things. Okay, so what am I doing? So we add in this part and we subtract. Man, I'm really bad at this. I really should have had something maybe pre-written up. We add this part, and we do subtract this part. Okay. And that goes up to a y. Is this even 2D things are hard. now we want to go from 0. Okay, so we want to go up, right? So the row is going to be 0, and then j for column, and we want to go to I-1j. And then we want to do this with prefix 2s. And I was just copy and pasting, but in the wrong way, so that's why this is wrong. Now we want to go I+1. We want to go to, yeah, we want to start from here, j. We want to go to R, j. Try premature optimization. I hope this doesn't time out, because this would be really sad if it does. And then now this is easier. So then we go from 0, no. We have I0 to I-1. No, still I, j-1. This is way awkward the way that I'm writing it. Because I didn't need a to the matrix, that's why. This is why this is awkward. To the prefix sum, I just needed regular prefix sum. Also, what? So now we start I+1, and then this is to C. And there might be performance ramification as a result. And then current. Okay, and now for, I don't know, okay. Let's run this real quick actually, see if it looks okay. Our range, that's not great. No, I guess technically in this case then I need this to be that. Yep, okay. Because it's inclusive, but okay. Maybe this is right, I don't know. Let's see. Okay. So many possible typos and stuff. Three and 0. Okay. As you can guess, this is way prone to silly mistakes, so let's give it a spin though. Hope it doesn't. And also don't time out. We have to do optimization if it times out. It's timing out, isn't it? Oh, okay. Well, that's actually surprising. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. This is a little bit of a sad contest for me. I'll see you later. Stay good, stay healthy, take good mental health, and take care. Bye bye.